Alright, day 15. So it's been a little while since I've actually sat down and done the admin of code. 3 days. So let's just do the latest one and I'll hopefully catch up at some point soon. Okay, lens library. Oh, I skipped a bunch of the load, didn't I? So I'm gonna go here. As you step inside, you are immediately greeted by a somewhat panicked reindeer wearing goggles and loose-fitting hard hat. The reindeer leads you to the shelf of goggles and hard hats. You quickly find some that fit, and then go further into the facility. No wonder you were loaded into the trebuchet so quickly. Okay. You pass through a final set of doors surrounded with even more alarming signs and into what must be the room that collects all the lights from the outside. As you admire the large assortment of lenses. Yep. Okay, a lot of stuff. Before you begin, please be prepared to use the holiday ASCII string helper algorithm. Appendix 1A. You turn to Appendix 1A, the reindeer leans closer with interest. The hash algorithm is a way to turn any string of characters into a single number from the range 0 to 255. To run the hash algorithm on a string, start with a current value of 0, then for each character in the string, start from the beginning. Determine the ASCII value for the current character. Increase the current value by the ASCII code. Set the current value to itself multiplied by 17. Set the current value to the remainder of the divided itself by 256. After following these steps for each character in the string in order, the current value is the output of the hash algorithm. So to find the current hash, do this. Okay. So the initialization sequence, your puzzle input is a comma separated list. Okay, so we get this as the input. Rn equals 1 becomes 30. We run it on the entire string, right? So okay, I'm gonna do the, I need to zoom in, don't I? Yes, like this. Okay, I'm gonna take the value hash var test, which is an array of const-u8 is equal to a string a. We can write function hash that takes in a string, which is a const-u8 array. Yeah, that's it, and returns between you. What is it? U8 can go up to 256, maybe. Let's try it. 2 to the power of 8 is what? 256 exactly. So it actually should work. So for string C, let's run through it. Determine the ASCII code of the current character of the string. Not a problem. Already done that. Increase the current value. Hash, which is u8 starts at 0. Increase by C. Set the current value. Let's make it a u16 because we could end up with overflows. Let's go u32 really to just doubly make sure. We could have overflows. We're gonna do hash is equal to hash set it to the self multiplied by times equals 17. Okay, set the current value to the remainder of dividing itself by 256. Hash is equal to hash, is it percent equal 256? Return at truncate hash. Local variable shadows declaration. Hash value. Hash value. And we're gonna print hash It's going to be a slice, or a string even. I'm going to ask for hash of A. Invalid for type U8. Oh, yeah. 52. Yeah. Great. That's fine. Good, that was. But now we need to run this, and the sum. So part 1, use size equals 0 for input line. Oh, actually no. Because it's just a singular, like a long line, so we don't need to do that. Var tokenizer equals standard.mem.tokenize sequence. The type is U8, and what do we take? Yeah, I always forget the buffer. So the buffer is input 0. Let's actually just say var line equals input at 0 line, and we're separating on commas. Let's take the input, the example input. We separate by commas, and while tokenize.next, I don't know, v part 1 plus or equal to the hash of v print part 1 part 1 nice. Very nice. So yeah, I'm very happy. This was a pretty straight. Well, I'm not going to say anything. Part 1 is pretty straightforward. Let's continue. You convince the reindeer to bring you the page. The page confirms that your hash algorithm is working. The book goes on to describe a series of 256 boxes, number 0 to 255. The boxes are arranged in a line starting from the point where the light enters the facility. Okay. The boxes have holes that allow the light to go from one to the other. Interesting. Inside each box there are several lens slots that will keep a lens correctly positioned to focus the light passing through the box. Along the wall, running parallel to the boxes, is a large library containing lenses organized by focal length, ranging 1 to 9. The reindeer also brings you a small handheld label printer. The book goes on to explain how to perform each step in the initialization sequence, a process it calls the Holiday ASCII String Helper Manual, Arrangement Procedure, or HashMap for short. Nice. Each step begins with a sequence of letters that indicates the label of the lens on which the steps operate. The result of running the hash algorithm label indicates the correct box for that step. The label will be immediately followed by the oh my god, this is so much information. Followed by a character that indicates the operation to perform, either an equal sign or a dash. Oh yeah, okay. If the operational character is a dash, go to the relevant box and remove the lens with the given label, if it is present in the box. Then go to the relevant box and remove the lens which with the given label. Then move any, oh my god, what? I'm confused. Okay, let's look at an example. So after this, we're gonna have box rn1, cm minus, so we're still gonna have that. qp3, cm is 2. Oh my god, like this is huge. Okay, I gotta start again. Each step begins with a sequence of letters that indicates the label of the lens on which the step operates. The result of running the hash algorithm on the label indicates the correct box for that step. Okay, the box for that step. Okay, great. The label will be immediately followed by a character that indicates the operation to perform. So the hash will give us the box, then we get the operation. If the operation is a dash, go to the relevant box and remove the lens with that with the given label if it is present in the box. Then move any remaining lenses as far forward in the box as they can go without changing their order, filling any space made by removing the indicated lens. If no lens in that box has been given label, nothing happens. If the operational character is an equal, it will be followed by a number indicating the focal length of the lens that needs to go into the relevant box. Be sure to use the label maker to mark the lens with the label given at the beginning of the step so you can find it later. If there is already a lens in that box, the same label, replace the on lens with a new one. Remove the on lens and put the new ones in its place, not moving anything else. If there is not already one, add the lens to the box immediately behind any lens. Okay, so we're shifting, we're going in the beginning. Don't move any of the other lenses when you do this. If there aren't any lenses in the box, then the lens goes all over the front. Okay, let's run through this. So after Rn equals 1, what did the number mean? Focal length. Okay. Okay, Cm minus, there's nothing in the box. If no lens in that box, nothing happens. Yep, nothing happens here, nothing happens here. Qp equals 3. So I'm guessing that gives you 1, like as the hash. Okay. Cm equals 2, I'm guessing that gives you 0 as the hash. So that means we're putting them after. Okay. Qp minus, so we're removing the operational characters at dash, go to the relevant box. Okay, so we do the hash on Qp. Actually, do we just do the hash on the result of running the hash algorithm on the label? Okay, just on the label. So we exclude the equals or the dashes or anything. So basically here, it would go QP, it would find that that's box 1, it would remove it. PC equals 4, so PC gives you box 3 apparently. Yep. Okay. And then we have OT9. So OT gives you box 3. You're putting it after the 9 there. AB gives you 3. So that goes after. PC minus, we remove PC. PC is 6, we add at the end. OT is 7. OT already exists, so we put it in there. Okay. All of them are always present. Only the boxes that contain any lenses are shown here. Within each box, lenses are listed from front to back. Okay. So Rn1 box 0 times, so 1, which is its focal length, times 1, because it's the first slot in the box, times 1, which is the focal length. Oh no, box 0 is the 1, so we do +1 from that stuff. Ooh, okay. Not the most straightforward, but it's okay. Okay, so I'm gonna leave part 1 then. Part 2, tokenizer, tokenize sequence. Oh no, to be fair, we probably can continue here. We're gonna ask what's the last character. If the last character is dash, if v at v dot length this one is equal to a dash, remove, else add. And what data structure we're going to use for this? I think we should have something like probably a map, or maybe we just create. No, we can create something, and we kind of we need like an array list. Yeah, okay, I know what to do. I'm going to have stand.page allocator. I'm going to have boxes equals try allocate the alloc, and we're going to allocate 256, and we're going to allocate pointers to standard.array list of pointers to array list which are going to contain a struct which is label. Actually, to be honest, yeah, we're gonna need label and focal length. Const lens equals struct which contains label. Const u8 focal length, which is also u8. Why not? Yeah, they all. Yeah, 1 to 9. It's pretty small. So, which an array list of lens. Okay. So. Are they always? No, they are not. So, if we are adding, we're gonna remove last two characters. So it's gonna be var label is equal to v. It's gonna go between 0 dot dot and then v dot length minus 2. And I really just want to see what this is. Print label, just in case. Type. What is this? Oh, do I not need try for alloc? Oh no, I do. It's just that I need the type comes first, right? So yeah, I think that's right. Let's go back to the test input. Yeah, that's great. I'm gonna just remove the last one. Then, okay. The index, which is equal to as usize the hash of the label, because we're going to need to index it, so it's going to have to be a usize there. Okay, so var list equals boxes at index. What's our index? And here there's some logic, right? So if it exists, we replace it with a new focal length. So for list box list dot because it's going to be a pointer to it, right? So dot star. No? Can I just use it? I'm not sure. Okay. If list dot include dot has no. Yeah, I guess it doesn't really have those types of things. And I'm going to initialize them all for boxes box. I'm just going to go box dot star. Okay, just box dot init. with an allocator. It's okay. No need to free memory. The operating system does it for us. For list box if box dot. Does it know what box is? No, it doesn't. What's a box of lenses? So it's going to be. That's kind of annoying. It doesn't actually, but box dot dot label. And so we're going to have standard.mem dot equal u8 this box dot label and the label. Okay. Exists equals false. Exists equals true. And we can break. If it exists, then actually we don't want to do anything. We want to replace. We want to go ahead and say box dot focal length is equal to yeah, we need to now take focal length equals try standard fmt dot pass int of u8, sure, and it's going to be v dot length -2 dot dot. I think that might be it. Yeah, okay. Focal length is equal to focal length. Okay. If not exists, then box list dot append lens dot focal length equals focal length dot label equals label. Okay, if we do have to remove it, I'm doing everything kind of at once here, so yeah, we're gonna do a very similar thing. We're gonna look for the index of the label, and then we're gonna have the list. The list is itself a box, right? So and yeah, I'm kind of mixing up terminology here, but okay, it's okay. So I'm going to look through the box like I did here. If there are any of them, I'm going to not swap, remove, order remove. Remove the element item, size shifting elements after. Okay. 0 dot I box dot order remove. What's going on here? Why can't I get? What's going on with my LSP all of a sudden? Not box, oh, list dot order remove at I. And now we can break. Yeah. Otherwise nothing should happen. Just what are the errors? Can I change that to not be a pointer? Just have an array of actual things. Oh, true. So for each one, we're gonna say was 0 dot boxes dot length I boxes at I equals standard dot array list of pointers to standard array list of lens dot init with a page allocator with an allocator. We might need to try that instead. array list. Does I not need a try then? What is your expected type pointer? Found array list. Oh wait, what is this? Does that work? List dot items. List dot items. Root structure file mem has no member named equals. Oh yeah, it's gonna be equal. Strange the LSP doesn't flag that, but okay. Expected. Oh yeah, base 10. Cannot reassign to thing. True. Can I grab its pointer? What if I do dot add star appends the index for that. We're gonna do box dot star dot length, focal length. What? Cast, discards, const, quantify. Yes, I've had this error before. I never quite know how to pin it down. Var box equals deleting side. Inside brackets, the pointer to box. So is that just it? Like I can separate it out. Errors ignored. Try append. Print tests. I'm actually not. I'm not sure what happens with the memory there, where it gets freed. B dot length minus 2 dot dot. Equals 1, so it's got to be 1 less, it seems. Test 1, invalid character. Oh, I gotta change it. Oh, yeah, actually there. Great. Well, I mean, we kind of just assumed that that works. Let's now actually test some stuff. We're gonna go through the boxes and through each one. So we're gonna the index of the box times the index of the other thing times the focal length. Okay. Great. Okay, so 4 boxes box and also 1 dot dot box index 4 lens box dot items lens. We're going to do R2 plus or equal to lens dot focal length, and we're going to do this as a use size. We're going to do this as a use size times. Let's start with box index times focal length. Oh yeah, that comes last, and then we do the first slot 1 dot lot. Part 2. Oh no. That's great. Just straight 0. Okay. Print lens any. Let's just take lens there. Huh. Boxes dot length. Oh, I don't. Why? Print boxes. Strange. And am I not iterating over them? Iterating. Alright, let's continue. Just had to have some dinner there. So, oh god, there's a lot of stuff. It seems that box items is not appending. Oh, and yes, I think I actually need to do var box equals allocator dots create lens, and then I think I need to go box dot focal length equals focal length, box dot label equals label, and I'm appending. Yeah, and then hopefully that fixes that. Oh, I need to try there, try append. Oh, so it's not a pointer? Great. That's so strange. Okay, but it's appending. For some reason, box items, still nothing. That's strange. List. List dot append. So it's appending. Box items dot length. Huh. It's weird. Weird, isn't it? Let's try just list just one. And no dash. So it exists. Let's do this. Let's print print boxes index. Okay, let's run. Part 130. That's not right. Oh no, part 1. Wait, where did this go? Oh, boxes index 0. Well, I just completely missed that. So we're appending, and right after we append, we should be able to print list length or something. I feel like this is some sort of memory issue. Let's print the items even. No, that's right. That's fine. Box 1 items. Boxes at 0. That's items or something like that. Huh, interesting. You see, like it okay, we append. What the what? No, that is strange, isn't it? That is quite strange. I think it is that problem with pointers. I think I've had this before, where this actually needs to be a pointer to an array list. So you need to be var array list and boxes at I equals the pointer to said array list. And then list is this dot star. And then yeah, that works better. Okay, and actually we got a number for part 2 now. That might be, oh no, it is not correct. Let's go 1 to 10 here. What? For loop of objects with non-equal lengths. Oh yeah. Let's just say if box index is equal to 10, we break. That's not right. Oh wait, no, that is. Oh. Oh wait, that is right, but that's very wrong in a few senses. Interesting. Okay. I think maybe box star dot label. We get segfault. Oh, that is interesting. Let's take step by step, and let's just get this one working. It's 45. It's just not. That's not correct. Box items. Box items. Yeah, we're getting some conflicts there. Is it to do with the initialization, you think? Like, is it? So we're initializing a list. No, I mean, I think that should be okay. They all have that one item. Print lens box dot items at 0 dot label. Yeah, they all have rn. So when we append, we would do list.append. We should only get that first one. List.star. But now that's not appending. Appending to we're appending label to the index. I think we can get rid of that for now. Appending rn to 0, but box 1 has items 0. So am I just severely misunderstanding how lists work? I think I really am. It's an interesting learning moment. So we're allocating a lot Right, so we're allocating pointers to to an array list of lenses, and then we're assigning boxes I to be the pointer. That's I mean, that should be okay, I guess, but it's not. But oh, now we kind of, yeah, now we have nothing. If I do boxes at 0 dot star or dot append, do I just do dot append? Pointer to bar L equals lens bro, and focal size is at 5 or something. The pointer to L. Errors ignored. Just try that instead. They all get it now. That's super weird. Huh. Yeah, that's really strange. What if I did this and then I could, yeah, let's just do that. Oh, sorry. Okay. Let's get rid of those dereferences. Okay, that works better. That works better. So we create lens and we append box. Box dot star dot box star dot, and we append box. See, that's just a bit weird to me. Length. This dot items dot length. Yeah, it goes away. I'm gonna do print test here and just always print the boxes 0 dot items dot length. Just always. So we append, and then this one, and after testing again, and it becomes 0. Yeah, like vanishes, disappears, goes from the world or something. That's pretty weird. That is pretty strange. I think I must be misunderstanding how structs are working, basically. Like, I'm misunderstanding something. Like, if I just add, I'm gonna add that second part, this one. So we got length 1. Each time. Testing 0, testing 0, testing 0. Testing 0. So every single time we append, but it just doesn't. Extends the list by one element, allocating more memory is necessary, and validates pointers if additional memory is required. Am I missing? Maybe I'm missing something. Let's just look at the book. Array list. Great. Array list. Array list sig. Array list of structs. Search array list of structs. Maybe we hold on. Maybe we append directly and not as a pointer. So nope. Oh, here we go. Undo. Items dot length I list dot items at I list dot items at I dot focal length equals that, and we can append. What was it? Oh yeah, focal length equals focal length dot label equals label. We can get rid of those. Like this. Appending. Yeah, that understands it. That's all good. But as soon as you go out again, it no longer likes it very much. Appending, and the list is 1. It goes back around. A box 0 length. Boxes 0 dot items dot length. Box 0 length. And we just down here is what? Come on. Let's just double check. Appended index. You know, maybe I'm looking into the wrong thing. Appending index is 0. It's definitely 0. Maybe if I do a pointer and then I can do dot star. Okay. So is it creating? I think it might have been creating a copy. This is interesting behavior I don't really know about. Maybe indexing something that should be a pointer, it creates a copy. That's really interesting. I might explore that. Huh. How about that? So we get 1, which I think is correct for that, yeah. What if we do them all? Oh, that's too much. Print box something length something else. Box dot items dot length and box index. Okay. So box 0 has length of 3 at the very end. Incorrect. So maybe let's run it until this one here. Cm equals 2. Okay, box 0 has 3. Box 0 has 3. Why does box 0 have 3? Print box 0 length. Boxes 0 dot items dot length. At one point it goes to 10. Because we are. What? Also, why does it run that many times? Oh, box index, and there we go. Box index of 1. Oh yeah, I suppose it is 1. So where are we? After yes, after CM2, box 0, box 0, but 1 has 2, and then box 2 has 1, and everything else is fine. Okay, maybe if we run it with the whole thing. Okay. We end up with box 1. Adds 2. And box 4 should have. Ooh. Okay, so we're not properly removing stuff, basically. After QP minus, I think I want to go here. So box 0 after QP minus has 2, but then at Q box 2 still has length 2. So that's not quite right. This ordered remove maybe isn't correct. Removing and before removing. Before removing. No, it did. But is this, oh, it's an issue with this thing again. Yeah, I'm going to go to the pointer and dereference it there. Okay, I think that looks more correct. 145. 145 is correct. And let's actually just remove this here and that if statement, and you pretty optimistic about this one. So alright, let's see if you are correct. You are correct. Okay, good. That was a really interesting day for learning about Zig itself, especially obviously those pointer issues with an array list that kind of seem to have created a clone of the items inside of it. That's really interesting. So we needed to index it, and you think that's a pointer, but no, you need to get the address of that object for it to be mutable, maybe. That's interesting. Yeah, maybe the index of that array, which was the array list, gave you an immutable copy but didn't reflect the underlying structure. Maybe it did a full copy of that index. Wow, interesting, really interesting. Yeah, I think that's a better problem to have than the other way around, whether you could make mutable changes to anything. In this case, you're probably less likely to change crucial underlying structures. But to be honest, I don't really know what I'm talking about. I don't even know if it's true. I think that's the hypothesis, I would say. But yeah, thank you for watching. Hopefully I'll do tomorrow. Yeah, I'll see you tomorrow, let's say. Bye.